Imagine a future where humanity has spread its wings beyond Earth, colonizing the vast expanse of our solar system. What would life be like on other planets and moons? How would we overcome the challenges of living in such hostile environments? Let's embark on a journey through our cosmic neighborhood and explore the possibilities of human colonization. Our first stop is Mars, the red planet. With its thin atmosphere and rocky terrain, Mars has long been a prime candidate for human settlement. Picture vast dome cities sprawling across the Martian landscape, protected from the harsh radiation and low atmospheric pressure. Inside these domes, colonists would cultivate hydroponic gardens, producing food and oxygen for the settlement. Water, extracted from the planet's polar ice caps and underground reservoirs, would be a precious resource, carefully recycled and purified. But life on Mars wouldn't be easy. The colonists would face constant challenges, from dust storms that could last for months to the psychological toll of living in an enclosed environment. Communication with Earth would be delayed by up to 20 minutes, making real-time conversations impossible. Despite these hurdles, the allure of being the first Martians would drive pioneers to push the boundaries of human endurance. Moving outward, we come to Jupiter's moon Europa. Beneath its icy surface lies a vast ocean, potentially teeming with alien life. Human colonies on Europa would be unlike anything we've seen before. Imagine underwater cities, protected from the intense radiation of Jupiter by kilometers of ice above. Colonists would live in pressurized habitats, venturing out in specialized submersibles to explore the alien ocean. The challenges of living on Europa would be immense. The crushing pressure of the ocean and the extreme cold would require advanced technology to overcome. Energy would be harvested from hydrothermal vents on the ocean floor, powering the colony's life support systems. The isolation would be even more profound than on Mars, with communication to Earth taking over an hour. But the potential discoveries on Europa could revolutionize our understanding of life in the universe. Imagine the excitement of finding the first extraterrestrial organisms, perhaps microbial life clinging to hydrothermal vents, or more complex creatures swimming in the alien sea. Let's venture even further to Saturn's largest moon, Titan. With its thick atmosphere and liquid methane lakes, Titan presents a unique opportunity for human colonization. Picture floating cities drifting on methane seas, harvesting hydrocarbons for energy and manufacturing. The dense atmosphere would provide protection from radiation and meteorites, making it easier to build open-air structures. However, the extreme cold of Titan, with surface temperatures around 179 degrees Celsius, would pose significant challenges. Colonists would need to develop advanced insulation and heating technologies to survive. The low gravity, about 14% of Earth's, would have long-term effects on human physiology, requiring constant exercise and medical interventions to prevent bone and muscle loss. Despite these challenges, Titan's abundance of hydrocarbons could make it a key fuel depot for further space exploration. Imagine massive refineries processing methane into rocket fuel, powering humanity's push to the outer solar system and beyond. Now let's consider a more exotic possibility: colonies on Mercury, the planet closest to the Sun. At first glance, Mercury seems an unlikely candidate for colonization, with extreme temperature swings between its day and night sides. But the planet's poles harbor a surprising secret: permanently shadowed craters that may contain water ice. Picture underground cities nestled in these craters, protected from the scorching heat and intense solar radiation. Solar panels on the surface would harness the abundant energy from the nearby sun, powering vast industrial complexes. Mercury's rich deposits of metals could be mined and processed, fueling the growth of a solar system-wide economy. The challenges of living on Mercury would be formidable. The intense gravity well of the sun would make travel to and from the planet energy-intensive. The lack of a substantial atmosphere would require all activities to be conducted in pressurized environments. But the potential rewards, abundant energy and valuable resources, might outweigh the risks for some intrepid colonists. Venturing to the outer solar system, we arrive at Neptune's moon Triton. This frozen world, with its nitrogen geysers and possible subsurface ocean, presents unique opportunities and challenges for human colonization. Imagine habitats built into the icy crust, using the natural insulation to protect against the extreme cold of deep space. Colonists on Triton would harness the energy from its cryovolcanic activity, tapping into the heat from the moon's interior. The nitrogen-rich atmosphere could be processed for breathable air, while water ice would be abundant. However, the extreme distance from Earth, over 4 billion kilometers, would mean near total isolation for the colonists. Supply missions would take years to arrive, and communication delays would stretch to hours. But the scientific value of a Triton colony would be immeasurable. From this distant outpost, humanity could study the outer solar system in unprecedented detail, potentially uncovering clues about the formation of our cosmic neighborhood. As we consider these potential colonies across the solar system, it's important to reflect on the broader implications of such expansion. How would our society change as we become a multi-planet species? Would we develop new forms of governance to manage colonies spread across vast distances? How would our relationship with Earth evolve as we establish footholds on other worlds? One possibility is the emergence of a solar system-wide economy, with different planets and moons specializing in various industries. Mars might become a center for agriculture and scientific research, while Mercury could be the industrial powerhouse, supplying metals and energy to the rest of the system. The asteroid belt could become a mining frontier, with automated robots extracting valuable resources from countless space rocks. Transportation between these colonies would likely rely on a network of space elevators, mass drivers, and fusion-powered spacecraft. Imagine massive cargo ships plying the space lanes, carrying goods and resources between worlds. Passenger liners might offer luxury cruises through the rings of Saturn or past the great red spot of Jupiter. As colonies become more established, they might develop their own unique cultures and identities. Martian colonists might pride themselves on their rugged self-reliance, while those living in the underwater cities of Europa could develop a mystical reverence for the alien ocean that surrounds them. Over time, these cultural differences could lead to tensions and even conflicts between colonies, echoing the geopolitical struggles of Earth's past. The expansion into space would also drive technological innovation at an unprecedented pace. The need to survive in hostile environments would spur advancements in life support systems, energy production, and materials science. Medical breakthroughs might extend the human lifespan, allowing colonists to survive the long journeys between worlds. Genetic engineering could create new crops capable of thriving in alien environments, or even modify humans to better withstand the rigors of space travel. But as we spread across the solar system, we would also face ethical dilemmas. How do we balance the need for resources with the preservation of alien environments? If we discover microbial life on Mars or in the oceans of Europa, do we have the right to potentially contaminate these ecosystems with our presence? These questions would challenge our notions of stewardship and responsibility on a cosmic scale. The colonization of the solar system would also have profound effects on our view of Earth. As we gain the ability to reshape entire worlds, we might develop a deeper appreciation for the delicate balance of our home planet. The sight of Earth as a pale blue dot in the vastness of space could inspire a new era of environmental consciousness and global cooperation. However, there's also the risk that some might see Earth as expendable, a used-up world to be abandoned in favor of new frontiers. Preventing this mindset and maintaining a connection with our ancestral home would be crucial for the long-term survival of our species. As we conclude our journey through this potential future, it's clear that the colonization of the solar system would be the greatest adventure in human history. It would challenge us in ways we can scarcely imagine, pushing the limits of our technology, our physiology, and our very conception of what it means to be human. From the red deserts of Mars to the icy depths of Europa, from the hydrocarbon seas of Triton to the sun-baked craters of Mercury, each colony would represent a triumph of human ingenuity and determination. These outposts of humanity would serve as stepping stones, propelling us further into the cosmos and perhaps one day to the stars beyond our solar system. As we face the challenges of the present day, the dream of becoming a multi-planet species offers hope and inspiration. It reminds us of our capacity for greatness, our ability to overcome seemingly insurmountable obstacles, and our unquenchable thirst for exploration and discovery. Who knows what wonders await us in the vast expanse of our cosmic backyard? What secrets will we uncover? What new horizons will we reach? The colonization of the solar system is not just about conquering new worlds, it's about expanding the realm of human experience, pushing the boundaries of what's possible, and securing a future for our species among the stars. As we stand on the brink of this new frontier, we must remember that the greatest challenges often yield the greatest rewards. The road to becoming a solar system-spanning civilization will be long and fraught with difficulties, but the potential benefits, scientific, technological, and philosophical, are beyond measure. So let us look to the skies with wonder and determination, ready to take our first steps into the cosmic ocean. For in the words of Carl Sagan, the surface of the Earth is the shore of the cosmic ocean. Recently, we've waded a little way out, and the water seems inviting. The time has come to dive in, to explore the depths of our solar system, and to write the next chapter in the grand story of human exploration. Follow us for more mind-bending explorations.